Hey everybody, Trey here. Welcome back to another video. Yesterday, Sunday, February 4th, we had a bit of a surprise tornado event across northern Florida and southern Georgia. Several supercells ended up developing, a few of which produced tornadoes, including this one, which may be the most notable of the event. This one occurred just southeast of Valdosta, Georgia, and from the footage that you see here, was a pretty beefy tornado. Ended up producing quite a bit of damage. Perhaps may even be rated as a strong tornado. We'll have to wait and see what the NWS damage surveys have to say. But as you can see from the footage here, it did produce some pretty significant damage. Some buildings wiped away there, and some homes as well, sustaining some pretty significant damage. So very well could be a strong tornado, but again, we'll wait and see what the NWS damage surveys have to say. There were also some other supercells that produced tornadoes, including this one just southwest of Jacksonville, Florida. Fairly weak tornado, but very photogenic at the same time. Was not planning on doing a full breakdown of this event, but as I was going through the data this morning, it looked like a pretty interesting event to go over. So that's exactly what we're going to do in this video. We're going to take a look at the meteorology behind this event and show you some of the reasons why initially it may have been viewed as more of a low-end threat and actually ended up perhaps overperforming just a little bit with some of these supercells and photogenic, perhaps strong tornadoes. So without further ado, let's go ahead and get started. With their morning outlook, the SPC had outlined a slight risk for the southern Florida peninsula into the Florida Keys for a tornado and damaging wind threat accompanying a squall line moving through with some embedded supercells, embedded mesovortex circulations across that region in the morning hours. And they also had a marginal risk outlined across the northern half of the Florida Panhandle into southern Georgia for a more conditional second round of storms that was possibly going to develop in this area farther north with a marginal tornado threat, perhaps a damaging wind threat, and an isolated hail threat as well. The midday outlook also kept that marginal risk, but trimmed it a little bit into just the northern portion, northeast portions of the Florida Peninsula into southeast Georgia, and they kind of kept that through the remainder of the day. I've seen a lot of comments regarding this setup and how it should have been a 5% tornado risk, a slight risk upgrade, 10% hatched tornado risk, and you have to remember that the SPC categorical outlook outlines are based on both coverage and intensity. So basically, if you have the threat for storms that is not expected to be very widespread, maybe you only see one or two storms that are going to possibly bring severe weather, even if those threats are expected to be possibly significant, you can't really issue a high risk for that. Same thing with the coverage, same thing with the intensity. If the storms, if you're going to have a lot of severe storms, but most of them will be just very briefly severe or produce very limited severe level hazards, then you can't really issue those higher risk categories. So yesterday, the threat was not expected to be very long-lived based on questions on instability. We'll get into that here in just a second. But instability questions as well as a coverage, some coverage concerns. We were not, possibly expecting to see a lot of coverage of storms. That lent itself to more of a marginal risk category. So I can definitely see why they kept the marginal risk throughout the day. We were expecting maybe a few severe storms, and those severe storms that would develop would not really be all that long in their duration of producing severe hazards. So, hindsight is of course 2020. Could they have added a slight risk in this region? Sure. But given some of the concerns over instability and over the overall duration of these storms within the most favorable environment, which we'll talk about here in just a second, they kept it at a marginal. I think that was certainly a fair thing to do. So definitely keep in mind that the SPC, these folks are the best folks in the business at this stuff. They know what they're doing, and I think they kept the marginal risk in for many reasons. Could they have upgraded to a slight risk? 5% tornado risk, sure, but I think the marginal risk definitely encapsulated the overall limited duration of the severe threat and coverage of the severe threat as well. All right, with that out of the way, let's go ahead and dive into the meteorology behind this event. We'll start off at 500 millibars yesterday morning, and our main player with this event, at least on the synoptic scale, was this very broad, closed 500 millibar trough slowly making its way across the southern portion of the country throughout the day yesterday. It had started off as a very negatively tilted open wave that had produced some severe weather across Oklahoma and Texas. If you were paying attention to weather social media over the last couple of days, you saw the tornado photos and video from parts of northwest Texas a few days ago near the town of Hamlin. Very photogenic tornadoes there. The system continued to move off to the east very, very slowly and really entered sort of an occlusion, weakening phase, taking on this more closed configuration as it moved into the southeastern U.S. yesterday. Very cold air aloft at the center of this trough. You can see the red dashed lines here. Those are our isotherms, lines of equal temperature. You can see minus 20, minus 22, minus 24 at the core of this 500 millibar trough. Closed low, and that was starting to overspread the region yesterday across parts of Florida and Georgia, and that was expected to help destabilize the atmosphere a little bit going into the afternoon hours yesterday behind the morning round of storms. But whether or not that would be enough to fully destabilize the atmosphere for robust convection was still a little bit in question. And that's why the SPC, at least initially, had maintained that marginal risk. We had this initial batch of storms here. Here's our wide view of the radar. As we talked about before, slight risk across the southern Florida panhandle yesterday morning for some more robust convection down there, some embedded mesovortex circulations in southern Florida yesterday, but lots of rain to the north of that as well. And that was expected to at least move out fairly quickly going into the afternoon hours yesterday. But since we had more southerly or southeasterly surface winds, we'll take a look at the surface pattern here in a second. The winds were expected to be out of the south-southeast. That was expected to pull a little bit more convectively contaminated rain-cooled air from southern Florida into the region of northern Florida and southern Georgia, where the secondary round of storms was expected to begin. So that was hampering the predictability of this second round of storms and making it a little bit more of a conditional threat. But this cold air aloft with this closed 500 millibar trough was expected to at least help somewhat in destabilizing the atmosphere, with very cold air aloft overspreading the region through the afternoon hours. Heading down to the surface, cyclogenesis was well underway yesterday morning as that upper trough was meandering slowly eastward along the Gulf Coast, and that surface low would deepen and move off to the north during the day to a position somewhere near the Alabama, Georgia, Florida triple point by 20Z, 3 p.m. Eastern Time, right about the time the Valdosta tornado occurred, which is right in there just ahead of the surface low. Now, one of the questions over the degree of the severe threat for the afternoon was how much the warm sector would begin pinching off going into the afternoon hours. So here we are at 15Z, surface low here just off the Florida Panhandle, just off the coast of the Florida Panhandle. We draw on our cold front here through the pressure tongue right in there. And our warm front was probably somewhere in this vicinity here, slowly translating northward with the northward translation of the surface low. Now, if we go to our position there at 20Z, as we just saw, surface low up in here, cold front now somewhere in this vicinity here, with our warm front draped somewhere off in this vicinity here. So you see how much less space we have here just ahead of the surface low, much more pinched off warm sector as we went on with time into the afternoon hours yesterday. And that was a reason that the SPC was a little bit unsure of the overall duration of the threat. If storms were to develop in the warm sector just ahead of the surface low, they may not have much time given the pinching off of the warm sector and their overall north-northwestward movement. That would give them very limited time within the warm sector to produce any significant severe hazards, and therefore the overall duration of the threat was in question. That north-northwest movement, though, was expected to take storms and pass them over the warm front, helping them to interact with that extra low-level shear and vorticity along that front. So that could have been a compensating factor for maybe the tornado threat that developed with some of these storms close to the warm front, specifically the Valdosta storm. You can see here at 20Z, once again, the surface low here, warm front right in here, Valdosta is right in here, so that storm is right on the warm front. But again, that north-northwest motion would take it very quickly across the warm front, making it elevated very quickly after it produced that tornado. So that was kind of some of the factors that the SPC was dealing with and that meteorologists in this area were dealing with over the overall duration and intensity of the severe threat. But if storms were to develop, they would have at least some time in the warm sector, and assuming enough destabilization would occur, which was an if, going into the afternoon yesterday, we would possibly see some more robust severe threats coming out of those storms. Moving on to our raw surface data at 20Z, 3 p.m. Eastern Time, just before the Valdosta tornado occurred. Once again, our surface low right in here, you see the counterclockwise circulation around that point, denoting the surface low center. Cold front draped probably somewhere in this vicinity here. You see the westerly flow across the Florida Panhandle, more southerly flow across the Florida Peninsula. So our cold front right in that wind shift there. Warm front as well, we see the wind shift from more southerly winds across the Florida Peninsula to more easterly winds across Georgia. So our warm front draped right there across southern Georgia. Valdosta is right in here. You see 60 over 57, fairly cool across northern Florida and southern Georgia. But that would be enough to destabilize the atmosphere. 60 over 57 at Valdosta. So in these kinds of setups with lots of cold air aloft, that can help overcome weaker low-level thermodynamics just a little bit. And that's exactly what we got here. Again, one of those questions during the morning hours was whether or not we'd see this rain-cooled air from the southern Florida Peninsula make its way northward on that southerly low-level flow, and that really didn't end up being too much of a concern. We saw these temperatures warm down here into the low 70s, and that would continue across the northern Florida Peninsula through the afternoon and support a little bit more robust instability for storms later on, especially our Jacksonville supercell and tornado that you saw earlier. But up here, we still were maintaining cooler temperatures right along the warm front, but it was enough with that colder air aloft coming in to help destabilize the atmosphere, enough to support fairly small, low-top storms with fairly robust convection. Now, you might be thinking to yourself, closed 500 millibar trough with lots of cold air aloft with a surface low in fairly close proximity. This sounds a lot like a cold core event, and you'd be right. This had a lot of the hallmarks of classic cold core events. I've shown this graphic before on the channel many times. This is adapted from Davies and Geyer 2004. I'll put a link to this paper in the description box below. But this is your typical schematic for a classic cold core type setup. If we look at the panel on the right here, we pretty much have what we saw yesterday in place. Cold front here draped down to the south and southwest of the surface low. Warm front off to the east. Where those boundaries intersect, you have your main focus point for convective initiation. We have relatively moist warm air moving up into that triple point area, and your favorite area for tornadic activity is right there ahead of the surface low, close to the warm front. That's exactly what we had yesterday. Now, it wasn't perfect. We did have a little bit of difference from an overall classic cold core setup, but the hallmarks were there. Large, closed low at 500 millibars with lots of cold air at its center. Surface low in fairly close proximity to the center of the 500 millibar closed low. Now, this wasn't perfect. Usually you want to see less than about 200 statute miles between the core of the 500 millibar closed low and the surface low. And here we were looking at about 300, 400 miles or so, but still with the large expanse of cold air here at the center of this trough, there was enough to, I think, overspread the area near the surface low, as we talked about just a little bit ago, and that helped to compensate for the somewhat more unfavorable distance between the 500 millibar low center and the surface low center. Additionally, we had our classic triple point setting up just ahead of the surface low. In this case, it was the intersection between our cold front and our warm front, and right ahead of that would be our favored location for storm activity. We tried to get that warm, moist flow up into this triple point area, dew points in the upper 50s to low 60s, a little bit less than what we often see here in the Gulf, but it was enough with temperatures remaining in the 60s and 70s here. We tried to get those 70s temperatures up into the warm frontal zone, couldn't quite get there. Again, 60 degrees at Valdosta at the time of this tornado, but still with dew points hanging out in the upper 50s, that was enough with the colder air aloft seeping over this area to support at least limited destabilization across this area. And we'd see more robust destabilization as these warmer temperatures made their way northward into northern Florida, going into the later afternoon hours for the storms such as the Jacksonville supercell you saw earlier. So classic hallmarks of a typical cold core setup with your 500 millibar trough and closed low and surface low in fairly close proximity. And even if in this case, if we didn't have that close proximity as we normally need for a cold core setup, we had a lot of cold air aloft with that expansive 500 millibar closed low that was overspreading the region, that triple point region right ahead of the surface low, which was our favored location for tornadic activity in this setup. This was quite an unusual setup, especially for this area, especially for this time of year. This is a setup you'd be much more likely to see in some place like the Midwest. It's not often in the Southeast you get these closed, occluded 500 millibar trough and surface low combos. Oftentimes this time of year you'll get these bowling ball troughs. with strong synoptic forcing for ascent. You get these widespread severe weather events across the southeast in the winter and early spring months. And it's not often any time of year you'll get these cold core-esque setups and cold core-esque tornado environments in the southeast, but this was certainly an example of that, and may have caught some folks off guard as far as looking for pattern recognition in this area. But as you can see here, it had a lot of the hallmarks of more of your Midwest and Central Plains cold core type setups, just translated south a few hundred miles into the southeast. Here is some visible satellite data from the morning into the early afternoon hours yesterday. Here's our complex of storms, lots of cloud cover associated with that complex moving across much of Florida during the morning hours. But behind that, it would give way to quite a bit of recovery and some destabilization due to surface heating. Plenty of breaks in the clouds here for ample convective development across the northern portion of Florida. So the recovery behind the morning storms did not end up being an issue. Again, what was perhaps a concern was whether or not the low-level air mass would be, that rain-cooled air from the south would be advected northward. But you can see down here to the south as well, we had quite a bit of recovery behind the morning round, plenty of sunshine to kind of recover that air mass that had been worked over from the morning storms, and that was being advected northward into the northern Florida, southern Georgia area. And so we didn't really see that issue come to fruition at all, but plenty of destabilization for storms. It was still limited. We didn't have all day for this area to recover, but we did have enough time, and along with the cold air aloft overspreading the region, that helped to at least give us weak destabilization across this area, just enough to support low-topped but robust convection. Here's our wide view radar again. Here's our storm complex moving through Florida through the morning. And as that surface low spun to the north, we got convective development just out ahead of it, just south of the warm front ahead of the surface low. And those storms with their northwestward motion would interact with that warm front, and those that did would produce tornadoes, especially the Valdosta storm. That was certainly fueled by its interaction with the warm front. And then eventually those storms would cross and disappear as they became elevated to the north of the front. Then additional convection occurred a little bit farther to the southeast toward the northeast Florida area. Jacksonville supercell came out of that cluster, and that was that. Here's a bit of a closer in view of the radar. This is from KVAX, which is at Moody Air Force Base, just east of Valdosta, which is right in there. Jacksonville right in here. This starts at 18Z 1 p.m. Eastern Time, and after that morning round moved quickly off to the north and northeast. We didn't have much behind it, and that allowed for convective development to occur just ahead of the surface low and move off to the north or north-northwest, given the ambient flow out of the south-southeast. So again, surface low right in here. These bands of convection were most likely to produce tornadoes, again, given our cold core schematic diagram and our pattern recognition from past cold core and cold core-esque events. These storms right ahead of the surface low, just ahead of the triple point, would be our best chance of producing tornadoes, and that certainly came to fruition. Multiple couplets within these storms, but this one right in here in particular was the one that became the most notable with our Valdosta tornado. It doesn't really look like much on radar. These were, again, very low-top storms given limited instability, and very small storms at that as well, but they were just enough. They had just enough instability to tap into that low-level shear and produce tornadoes. And then down here we had additional convection across northern Florida. That would be in a little bit more instability-rich environment. We'll take a look at that in just a second, but as those 70s temperatures crept here into northeast Florida, we had mixed layer Cape increase a little bit from our areas farther north along the warm front. That allowed for these storms to become a little bit more robust, and this supercell right here was the one that produced the tornado on the southwest side of Jacksonville. Here are a couple of RAP model proximity soundings near these supercells as they were ongoing. This first one you see here is from Valdosta, so very close to the tornado that occurred southeast of town. Very limited instability, only about 300 joules per kilogram of mixed layer Cape. This might be just on the north side of the warm front, given the easterly surface winds, but it is close enough to give us a very representative environment. 62 over 59 at the surface, so cool surface temperatures, but with a 59-degree dew point. Relatively speaking, that's a fairly moist environment, and with the cold air aloft seeping in, that was enough to give us weak but concentrated destabilization in the lowest few kilometers of the atmosphere. Our 500 millibar temperatures right in there's our 500 millibar mark on the temperature profile. Looks to be just below minus 20 degrees Celsius, so fairly cold air aloft overspreading the region, helping to overcome the cool surface temperatures just north of the front, which would be somewhere where we'd expect storms to be fairly elevated in this kind of a low-level temperature profile. But with the cold air aloft, again, that was able to give us at least a few hundred joules per kilogram of mixed layer CAPE. And again, it was all concentrated in the low levels of the atmosphere. 0 to 3 kilometer CAPE in excess of 150 joules per kilogram. That is very, very impressive low-level instability. We've talked about this before. When you have strong low-level instability, that can stretch any spin in the low levels very efficiently into the vertical, and that can help aid in tornado genesis in certain environments. So instability definitely at first glance on the low side, but when you take a look at the configuration of that instability in the vertical, it was certainly favorable for low-topped but fairly robust convection, given strong low-level instability. Wind profiles looking fairly impressive as well. Strong curvature there in the low levels of the hodograph, strongly veering and strengthening winds in the low levels of the atmosphere. Again, we are just on the north side of the warm front, I think just barely on the north side of the warm front given due easterly surface winds, but still we were basically right on it, and therefore that gives us a very good environment. Good sense of the wind profile. So very long looping hodographs here, about 50 knots of effective bulk shear, so plenty of shear for supercells. And with just enough instability and that deep layer shear to work with, that was going to allow any updrafts to spin as they got going. But strong low-level shear as well. Effective storm relative helicity in excess of 350 meters squared per second squared. So lots of low-level shear for these storms to work with, especially along the warm front where that low-level shear and spin is maximized. Lots of streamwise vorticity as well. Again, streamwise vorticity, as we've talked about many times before on the channel, is when you compare your storm relative wind vector, which is drawn to the low levels of the hodograph in this case, and our horizontal vorticity vector, which is always perpendicular and to the left of the hodograph. When those two vectors are parallel to each other, you have a high streamwise vorticity environment, and you can see that that is definitely the case here in the low levels. Those two vectors very much parallel to each other, and that is definitely going to aid in tornado genesis when you have discrete supercells at play. So a very favorable environment, despite on the surface looking like a very weakly destabilized environment. It is just enough when you have strong shear and strong low-level shear at play, especially with a surface boundary in the mix. You're probably going to get some tornadoes out of that setup, and that is certainly what we got yesterday. I also pulled a vertical wind profile from the Valdosta radar at 1930Z, so about 40 minutes before the Valdosta tornado occurred. And we can see many of the same things. Very strong curvature in the low levels of the hodograph, 0 to 1 kilometer storm relative helicity in excess of 400 meters squared per second squared, so very strong low-level shear. You can see the low-level winds changing. Surface winds out of the south-southeast at about 15 knots or so, changing to about 50 knots out of the southeast at 1 kilometer above the surface. So very strong low-level shear in this environment. And even though we had limited instability, any more robust updrafts were able to tap into this very strongly sheared environment. Here is our RAP sounding from Jacksonville at 21Z, so just before the southwest Jacksonville tornado occurred. As we just discussed, a little bit stronger instability here, over 850 joules per kilogram of mixed layer CAPE. A little bit higher surface temperatures and dew points, 65 over 62 at the surface, so a little bit better destabilization with southeast extent. That, coupled with the colder air aloft seeping in, helped to really destabilize the atmosphere down here, especially in the low levels as well. 0 to 3 kilometer CAPE in excess of 200 joules per kilogram, so very strong low-level instability, again, helping to stretch any low-level spin into the vertical to potentially aid in tornado genesis in these supercells. We were not quite as impressive with the wind profile here. Farther to the southeast, we were farther removed from the warm front, so hodographs were not quite as large and looping here, but still plenty of curvature in those hodographs, plenty of veering and strengthening of the low-level winds with height leading to just under 300 meters squared per second squared of effective storm relative helicity, so plenty of low-level shear for these supercells to work with. These updrafts were going to be a little bit more robust down here, a little bit better chance for these to produce tornadoes, even away from the warm front with even stronger low-level instability. So certainly a favorable looking environment for tornadic supercells, perhaps not significant tornadic supercells, but with enough instability, especially concentrated in the low levels of the atmosphere, with ample low-level shear. This was going to be an environment where tornadoes were certainly possible with any more robust updrafts. All right, that's going to do it for this video. Hopefully you learned a few things about why yesterday was a pretty interesting day as far as tornadic activity goes. Definitely an unusual setup for this area this time of year. It's not often you see these cold core-esque setups in the southeast, really any time of year, especially now during the winter and early spring months. But sometimes you can get some setups that you just don't expect in certain areas, but they can still produce some interesting activity, as we saw yesterday. We'll have to wait and see what the NWS says about these tornadoes, especially the Valdosta tornado. Wouldn't be surprised to see an EF2 plus rating on that, depending on how well those buildings that were destroyed were built. But it looked at times like this may be a strong tornado, but we'll have to wait and see. But overall, a very interesting setup, very cold core-esque setup. I love looking into these types of setups as they really can produce some prolific tornadic activity, very chaseable and very visible tornadic activity as well. And certainly yesterday was an example of that. So with that, thanks for watching, and we'll see you in the next video.